role clarity, personal satisfaction, faculty of color, and gender. When I ran my SPSS output, I always like to highlight the variables that I should be looking at. And then I go back and, there we go. And then I go back and look at them in a specific order. First, I go to the assumptions to see if they are met. So for this first assumption, I don't know if my computer is moving as slowly to you all as it is to me, but the scatter plot assumption, on that top row, we're comparing all of the predictor variables to the dependent variable, which is campus satisfaction. So for these columns here, they, I said that the dichotomous variables, if they look like this, then they are considered not violating the assumption of linearity. These two here, I can't remember what they are. Let me scroll down a bit.
That's okay, you can skip.
Personal satisfaction and role clarity. They meet the assumption of linearity. Student relations is questionable. But anyway, like Dr. Vista said, I still ran the test. It was requested of us. Let's see, I'll just scroll through these pretty quickly so you guys can get an idea of what my output looked like. All right, my syntax, of course, 329 participants. And I think I noted that when I added faculty of were questionable, there could be a possible issue of multicollinearity. It is at 0.526. I have it highlighted in light blue so you guys can see it. In that yellow column, those are the correlations to campus satisfaction. You can see that all of them are correlated with the exception of gender. And the same was true when we used 4 variables or 6 variables. Also, that instance of multicollinearity, that was also the same in both cases. See, variables enter table, we have enter selected under methods, which indicates that we are running a simultaneous multiple regression, or that all predictor variables are being considered at the same time. Just confirms that the model that's created is statistically significant, and in this case it is. And so when we report that in our results, we report it as F. We put our degrees of freedom for the residuals, and I forgot that other column, but we report that F value along with the significance level. I'm not sure if we're supposed to report effect size. I did not for the ANOVA table. For the coefficients table, this kind of goes back to what Mr. Smith talked about at the beginning of the class. I looked first to see if the predictors were statistically significant. After I confirmed that they were significantly contributing to the model, in this case, role clarity, personal satisfaction, and color, then I looked at those standardized coefficients, because in my reports, I would say that role clarity contributes the most to the equation, but also personal satisfaction and faculty of color when student relations and gender are present. Over here is the tolerance, and I'm sure you guys looked at all of this before, but the tolerances are all above 1 minus the variance. I think I skipped that table by mistake. I did, right here. The variance is 0.538, which means that this model that's produced accounts for 54% of the variance in the dependent variable, which is campus satisfaction. This model can explain 54%. So in order to figure out what an appropriate tolerance level would be, we would subtract that value from 1. And the answer is whatever 1 minus 54 is. I can't think of But anyway, so all the tolerances are greater than that value. Now, our book said that partial, under this correlations part here, that we would take the partial value and we would square it in order to determine what the unique variance is for each variable. The video that we looked at said that we would look at the part value and square it. I don't know if there's a big difference, Dr. Vista, but in this case, we can see that it confirms what our beta coefficients tells us, and that's roll clarity contributes the most, or has the most unique variance with regards to this equation. For our collinearity diagnostics, this particular table was interesting to me because in the first table, when we only had 4 predictors, two of these predictors had variance on the same dimension. But for some reason, when we added faculty of color, the 3 variables had the most variance on dimension 5, which could be an issue of multicollinearity. All of the eigenvalues are lower than 1. All of the condition indexes are less than 15 with the exception of dimension 6, which is something that we look for as well. And then of course, we don't go over the residual statistics. We're looking at the scatter plot last, but this is something that we actually should consider first when we're looking for assumptions. And this confirms 2 of the assumptions. First, it confirms the normality of errors, and it also confirms that the residuals of the variances are constant. So that's assumption or condition 2 and 3. We talked about linearity already. And so I basically just gave you the interpretation as we were going through it, but I'll show you what my report looks like. And I went extremely formal this time around just because we were talking about reporting it in APA format, but I can be less formal from here out. But a simultaneous multiple regression, we examined campus satisfaction, and then of course I put the means, standard deviation, and inter-item correlation in that first table, which I'll show to you. This is what I meant here. I didn't report my effect size because I remember from the first class how that we need to make sure that we're reporting value from our. I used Cohen's. Oh, I have it right here. I don't know. Oh, you can't see my screen. Can y'all see my screen? You can't see my screen because. Anyway, I have the book in my hand. It's on chapter 6 of our first book where we're interpreting effect sizes for the R family and R squared. An effect size of 0.49 or greater is considered, if y'all will remember, a much larger than typical effect size. So here our adjusted R squared is 0.538, which means, of course, that it's 54% of the variance. And so according to Cohen, that's considered a much larger than typical effect size. Here are my tables. So there's our sample. Oops, sorry, too much. I have no idea. Oh, there we go. Okay, there's the second table because I scroll entirely too fast. But I'll just let you look at that while I'm waiting on the table 3 to come up. But these are all of my standardized beta values along with their significance levels, in addition to the unstandardized beta values. And these are what we would actually use in a prediction equation. So you might see an addendum to my response that I submitted for module 2. My equation for question 5, I use that, it's the old algebra equation from middle school, y equals mx plus b. So that y-intercept, that constant is 0.51. And then we add plus is 329. There we go. And here is that value that we highlighted earlier that we said could possibly indicate multicollinearity. Down here, I probably have too many. I was gonna ask Dr. Vista about this. Should we just choose 1 or 2 significance levels to indicate in the chart? It's just that some of them were significant at different levels.
We choose all 3.
Okay.
Yes,
Okay.
these are the standard one I said earlier. We choose all of them.
Okay, good deal. Table. The correlation table that was, I think it's the 3rd table that's produced in the output. That's all. I'm open to feedback. I appreciate